Hello, hello. So today we are going to endeavor into 8-7, which is where we're going to learn how to simplify radicals. So radicals play a very big role in this unit, especially when we learn how to use the quadratic formula and completing the square. So if you don't understand radicals, it's going to be very hard to do the equations we're going to be learning how to solve tomorrow. So here's what we do. This symbol right here is a lazy radical. Here's what your radical should look like. Your radical looks like this always. It looks like one of these two. Sometimes I write it like this, but generally speaking, you make a check, go up, and then out. That's your radical. Here's exactly what a radical does. It asks the question, what number times itself will equal the number under the radical? It's also called the square root. So for instance, if I had the number 9, and I type that into my calculator, I would get 3, because 3 times 3 is 9. If I had radical 4, I would get 2, because 2 times 2 is 4. So that's going to be some of the things we're looking at today. This thing right here is called the cube root. The cube root. That's basically saying what number times itself 3 times will equal the number under the radical. So the way we're going to approach radicals is simply by doing prime factorization. We just write the number in terms of all the prime numbers that multiply to it. So our first example is going to be the square root of 16. So we did prime factorization a few months ago when we learned how to factor. So all we do is we basically just say the numbers that multiply to 16. What multiplies to 16? 2 and 8. I then say to myself, what makes 2? Oh, 1 and 2, it's prime, so I don't do anything. I just circle it. I then say, what makes 8? You guessed it, 2 and 4. And again, I circle my 2 because nothing makes 2 except 2 and 1. I now say what makes 4, and I get 2 and 2. And I circle. Here's your next step of the radical process. You write down all the numbers we circled under the radical. So I'm now going to draw a radical symbol. And I'm going to put 4 2's under it. 1, 2, 3, 4. Here's your next step. You want to circle the doubles. I have a double here. And I have a double here. I now bring 1 out. 1, 2. What's 2 times 2? 4. That's basically saying the square root of 16 is 4. Another way I could have done this question, what times itself is equal to 16? 4. So now let's look at the next example. We don't have to go through the whole prime factorization way for every single question. We only have to do it for the ones that are not perfect squares, which you'll be seeing shortly. In the square root of 64, I say to myself, what makes 64? 8 and 8, so it's got to be equal to 8. Circle my double, bring it outside. That's how I get my 8. Now I go on to the square root of 24. I say to myself, what makes 24? 2 and 12. I circle my 2. What makes 12? You can do 4 and 3 or 2 and 6. And remember, we're always multiplying. So I now circle my 2 again. And now I say, what makes 6? 2 and 3. And you're always circling your primes. And by definition, a prime number is a number that can only be multiplied by itself and 1. We now write down all of our circled numbers under our radical. So I'm going to write 1, 2, 3 2's. 1, 2, 3, and then I write the number 3. I circle my doubles. I have a double 2 bring it on the outside. Double on the inside becomes single on the outside. Which means that my 2 times 2 just becomes a 2. If you look on the inside, there's nothing for my 2 to double up with now, or my 3 to double up with. So I just do 2 times 3, and that gets me a 6. So my final answer is 2 radical 6. That is what radical 24 is equal to. And that's all you do for these questions. If I were you, I would try to do example number 4 by yourself. So you can hit pause if you want to go through it by yourself, or you can watch me go through it. I say to myself, what makes 48? 2 and 24. Circle my 2, it's prime. What makes 24? 2 and 12. Circle my 2, it's prime. What makes 12? 3 and 4. Circle my 3, it's prime. What makes 4? 2 and 2. Circle them all, they're prime. Okay. I now write down all my circled numbers on the inside of my radical. So I'm going to write 1, 2, 3, 4 2's. 1, 2, 3, 4. And I'm going to write down my 3. Double on the inside, single on the outside. Double on the inside, single on the outside. Left with a 3 on the inside. 2 times 2 is 4, and then I'm left with a 3. That's basically saying that the square root of 48 is equal to 4 square root 3, or 4 radical 3. That is the level of difficulty of questions that you're going to be expected to deal with. However, one way that we can bring this a little deeper is actually making you figure out, like, oh, how do I now expand radicals or condense radicals with variable exponents? So let's do number 5 together. In this example, I have the square root of 72 times x squared. Here's how we approach. It's the exact same way we approach the other examples. We take our prime factorization of 72. What I do is I just keep on dividing by 2. 2 and 36. Circle that 2. I can divide this by 2, but I'm actually going to do 6 and 6 this time because I know 6 times 6 is 36. And then I'm going to break apart the 6 and do 2 and 3, 2 and 3. Those are all prime, so I'm going to circle. And now what we're going to do is we're going to write down radical. 1, 2, 3. 3 2's. 1, 2, 3. And then 2 3's. But now you're probably wondering, what do I do to this x squared? Well, it's actually pretty straightforward. All you do is write down how many x squareds you have. Well, you have 1 x squared, but you got 2 x's. So 1, 2. So I circle my doubles, double on the inside, single on the outside. I have a double 2. I have a double 3. And I have a double x. So I now just multiply. 2 times 3 times x is 6x. And then I just have a radical 2. That's basically saying that 72x squared is equal to 6x radical 2. Now, number 6 is a little more challenging. What I'm going to recommend is that we actually pretend that the 5 is not there. What we're doing for this example is we want to do 5 times the square root of 98 times x to the third. All we're going to do is just focus on this 98. I know that 49 and 2 make 98. Circle my 2. And then I know that I have a 7 and a 7 that make 49, and those are prime. I now do my 5 on the outside, and I put all my circled numbers on the inside. So I put my 2, and then I put my 7s, and then I write down x 3 times. Double on the inside, single on the outside. This 2's got nothing to double up with, but these 7's can double up. So I bring them on the outside. I have 3 x's, but I only have 1 double. And boom, they go on the outside as well. So my new radical, or my new expression, is just going to be x times 7 times 5, which is actually just 35x, radical 2x. That is your final answer. Again, this is mainly just to make sure that we know how to simplify radical expressions. If you know how to do numbers 1 through 4, tomorrow's lesson will be very straightforward. This part is just meant to maybe sort of enrich ourselves to make sure that we can do the fullest capabilities when it comes to radicals. Because when you take the SAT, this is the level of difficulty you'll be given. Now I'm given the cube root. So this is going to be our first cube root example. I want to find the cube root of 27. So now instead of doubles on the inside, single on the outside, it's going to be triple on the inside, single on the outside. So I say to myself, what makes 27? You guessed it, 3 and 9. Circle the 3. What makes 9? 3 and 3. Circle them. I now write them under my radical. So I get the cube root of 3 times 3 times 3. But the thing is, we're now doing the cube root, or the third root. So I want triples. If I look, I actually do have a triple 3. So triple on the inside, single on the outside. So my final answer is just 3. Because 3 times 3 times 3 is 27. Now, what I would like you to do is, if you got to this point of the lesson and you're like, you know what, this actually isn't that bad, I want you to try number 11 by yourself. I'm just going to post the solution in a moment. So I did my prime factorization of 81x to the 6th and got 3 times 3 times 3 times 3 times x times x times x times x and so forth. Triple on the inside, single on the outside. I have 1 triple 3 and I bring it out. I have 1 triple x and I bring it out. And I have another triple x and I bring it out. So I have 1 3 on the inside. Oh, I almost made an x. Oh, supposed to erase. And I get 3 times x, which is just 3x squared. So my final answer for the cube root of 81x to the 6th is 3x squared to the cube root of 3. So if I were you, I would go through these examples. I would have actually made sure that you were writing these down as you went through them, because your independent practice is going to be very much like examples 5 and 6. You need to know how to do the prime factorization of these numbers. So your independent practice is basically, you're just going to choose a column. You're going to do 5, 7, and 9, or you're going to do 6, 8, and 10. You decide. You only have to do 3 questions. Make sure that you write 1 question on the Google Classroom. That way we can capture your attendance. If you have any questions, please don't hesitate to email myself or Miss Townsend. Have a great day, ladies.